Section 4.3, Logarithmic Functions, Part 2. When we start to work with logarithmic functions, what's a log function? You have log base A of x. Here is your base. Base A. It's helpful to know properties that go along with logarithms. It helps us work out what we need to, or simplify what we need to, a lot quicker. Okay, so our first property says log base A of 1 is 0. No matter what the base is, if we're log base A of 1, we're always going to get 0. For example, let's say we do log base 5 of 1. That's going to be 0. Whatever the base is, if we're logging 1, we're going to get 0. Log base 8 of 1 is 0. No matter the base, if we're log basing anything 1, we're going to always get 0. Okay, so these two go together. In the last part, we saw logarithm functions and exponentials are inverses of one another. They undo one another, like x squared would be undone by the square root, or if I did the cubed root of x and I cube both sides, these undo one another, so we just get x. These undo one another, so we just get x. That's going to be how the log and exponential properties work. If I have a log to undo it, I do an exponential. If I have an exponential and I want to undo it, I do a logarithm. They're inverse functions. They undo one another. So in the case of property number 2, this is log base A, this is exponential A to the first. Since they're inverses, they cancel out, and I just get 1. Log base A of A to the x, these are inverses. They undo one another, so we're left with x. Exponential base A, log base A, inverse functions, they undo one another, so we get x. We're looking at how can I undo a logarithm? I do its inverse, exponentiate. If I have an exponent, how do I undo an exponential? I logarithm of the same base. And that's what we want to think of when we're doing logarithm properties. Okay, so problem number 10, express the equation in exponential form. So we have a logarithm and we want exponential form. Exponential form would be f of x or y is a to the x power. That would be our base. Okay, so here's a logarithm. I want to write it exponentially. So all I have to think of when I use my properties, all I have to think of is what's going to undo a log base 5. That's an exponential base 5. We're going to exponentiate base 5. Because we have a log 5, to undo it, I exponential base 5. Okay, so what that means is that 5 becomes the base, and this becomes the exponent of 5. 5 becomes the base, and this becomes the exponent of 5. Exponentials and logs undo one another, so this would become 1/5 is equal to 5 to the negative 1. Okay, how do I undo a log base 4? I exponentiate base 4. These cancel out, so we get 64 is equal to 4 cubed. Okay, log 6. How do I get rid of a log base 6? I exponentiate base 6. An exponential base 6 undoes this log 6. Whatever I do on the left, I must do on the right. Those cancel out. Z is equal to 6 to the first. Okay, we're going to exponentiate base 10. This is a log base 10, so I'm going to exponentiate base 10 on both sides. Exponentiate means this became the exponent of base 10. This became the exponent of base 10. These cancel out, so we get 3 equals 10 to the 2t. We're expressing the equation in exponential form. Okay, ln. What was the base of ln? E. We're going to exponentiate base e on both sides. Exponential base e undoes a log base e. They're inverse functions. They undo one another. So we end up with x plus 1 is e squared. We're just expressing the equation in exponential form. Okay, so what undoes a log base e? An exponential base e. So this is the new exponent of e. This is the new exponent of e. But because these are inverse functions, they will undo one another. So we get x minus 1 is equal to e to the fourth. Later, we would move that 1 over by adding, and then we've solved for x. But that's going to come up in the later sections. Express the equation in log form. Now we have all exponential expressions. This is an exponential expression. Exponential, all these are exponential expressions. But now we want to expand to log form, something that looks like this. Okay, so what do we have to think? We have to think, what undoes a logarithm? What is the inverse of a logarithm? The inverse of a logarithm is an exponential. So if I have an exponential, what's going to inverse the exponential? A logarithm. They undo one another. Okay, so if this is exponential base 6, then I want to log base 6 on both sides. These cancel out, so we'd end up with 2 equals log base 6 of 36. I have a logarithmic form. I have a logarithmic form. Okay, so this is base 10. If I have an exponential form, base 10, I'm going to log base 10 to undo that exponential base 10. If I log 10 on the left, I got to log 10 on the right. Exponential and logs undo one another, so those cancel out. You end up with negative 1 equals log base 10 of 1 over 10. Okay, base 3. We're going to log base 3, both sides. Once we log base 3, both sides, we chose 3, so I can get those to cancel out. 2x equals log base 3 to the 10. What base would you use here? That's base 10. Good. So we're going to log base 10. We're going to log base 10, both sides. There we go. Okay, we chose base 10, so those cancel out. Negative 4x equals log base 10 of 0.1. That's all they want, is just the logarithmic form. Okay, here's an exponential expression. What undoes an exponential? What undoes an exponential is a logarithm of its same base. What base is this? This is base e. So we're going to ln both sides. Ln of e cancel, so we get x plus 1 is the ln of 0.5. Okay, here's an exponential base e. To get rid of an exponential, we use a logarithm of the same base. So we want a logarithm base e. If I ln the left, I must ln the right. Well, we don't have an equivalent expression. Ln of e cancel out. 0.5x equals the ln of t. And there's properties of logarithms.